friends, myself Vicky Grua. Today we discuss the dimension formula and its applications. When we start to write a dimension formula, as we discuss what is dimensions, that is power that is raised on the fundamental units to represent a derived units. So how you will write a dimension formula? We will see it by a given example. Suppose if I want to find out the dimension formula for velocity. How can I find out the dimension formula for velocity? So first of all, we have to write the formula for velocity, that is displacement over time. As you know, the fundamental symbol of displacement is L and the symbol of time is T. So if you are moving with that, you can get the Lt minus 1. So here you can see we raised the power of 1 on the expression of L and minus 1 on T. So this Lt minus 1 will represent the dimension formula for velocity. In the similar process, we can get the different dimensional formula of different physical quantity. Generally we got the dimensional formula for derived quantities. We can take another example like acceleration. What is acceleration? Acceleration is defined as the rate of change of velocity, means simply I can say change in velocity upon time. I can write over here change in velocity over time. When you are going with change in velocity, what is change in velocity? Definitely it's the unit of change in velocity will be the same as the velocity. As we already got it, its unit is meter per second. So here also I can write Lt minus 1 by T. So in other form I can get Lt minus 2. So this is the dimension formula for acceleration. In the similar process, whatever be the units or the physical quantity given to you, you can find out a dimension formula for the given physical quantity. Suppose we take another example like suppose I'm just taking linear momentum. If I will define the linear momentum, it is defined as the product of mass and velocity. So I have written here m into v. M for mass and V for velocity. Clearly, what about the formula, what is the unit of mass? I certainly say it's kilogram. So I will write kilogram. If the unit of velocity, I will ask for unit of velocity, it will be meter per second. So I am writing here meter per second. So it means the unit of linear momentum should be kilogram meter per second. But if it is asked to write its dimension formula, so how you will use the dimension formula? As we have discussed earlier, you can write for kg, you can use the symbol m, and definitely there is power 1 on kg, so there is a power of 1 on m. And for mass, this m represent here length, so for this part you have to write L per second. So you have to write, because it is in upon, so you have to write T to the power minus 1. So m to the power 1, L to the power 1 and T to the power minus 1 will gives you the dimension formula for linear momentum. Here it is worth noting that sometimes the another physical quantity can have the same dimension formula too. For an example, this linear momentum, there is another physical quantity which have the same dimension formula. So you have to collect all these physical quantity which have the same dimension formula. For example, this linear momentum has a dimension formula of mLt to the power minus 1, and which also is a dimension formula of impulse of force. So you can see different physical quantities can have the same dimension formula, may or may not their formulas are same. Maybe their formula are same, maybe their formula are not same, but they may have the same dimensional formula. In the similar pattern, we can get various different dimensions formula for other physical quantity like work, torque. They have the same dimension formula. Energy has the same dimension formula too. So if I will write for that also, I can get work, torque. One more thing is there. If I am writing dimensional formula, so what I will do, I will take a big bracket to find out dimension formula. So I can write it like that: torque or energy. When I'm saying energy, energy of any type, heat energy, electric energy, whatever it is, and they have the dimension formula of work is force into displacement, like mass into acceleration into displacement. So it will be mass m L t minus 2 and L. So it has a dimension formula of m L2 t minus 2. So if it is asked what is the dimension formula of heat energy, you have to say m L2 t minus 2. If it is asked to you what is the dimension formula of electric energy, it will remain the same. So in this way you can find out the process how we get a dimension formula. Now we discuss the use of dimensional formula, how the dimension formula is helpful for us to teaching physics. The first of all, we can see if I want to check the correctness of a physical equations, dimension formula is very worth noting for me, and how I will proceed to check the correctness of the given equation. Suppose I've got an equation like S equals to ut plus half at square. This is a physical equation. This physical equation dimensionally correct. If I am saying dimensionally correct, means all different terms in this equation should have the same dimension formula. This process is called homogeneity of equation. Whenever I have written an equation, all terms of that equation should have the same dimensional formula. So we can check whether this formula is dimensionally correct or not. First of all, you can see on the left side it is written as S. S stands for distance here. So if I will find out the dimension of S, I can write like L. Left hand side should have the dimension of L. What about the dimension of ut? As U stands for velocity, T for time. Now as we already know what is the dimension formula of U, velocity, it is Lt minus 1, and for time it is T. So when we proceed for that, we can get again L. If I will move for half at square, A stands for acceleration, its dimension formula is Lt minus 2 and T square is T square. So again I can get the same dimension formula. So you can see that every terms of this physical equation have the same dimension formula. So this formula is dimensionally correct. So if the dimension of left side and right side are same, we can say this is dimensionally correct. But here it is worth noting that this half at square, this half has no dimension. So when we are moving to find out the dimensionally correctness of the formula, we can't say whether this formula is correct or not. But the formula may be dimensionally correct. Maybe that formula is overall, that formula can be wrong by mathematical. Okay, let's take another example. Suppose time period will be equals to 2 pi under root L by J. This is the time period of a simple pendulum. Will this expression is true or wrong? Again I am just saying the same words. If this equation is true, then the left hand side or the right hand side should have the same dimension formula. Again, if I will take the dimension formula of time, it will be T again, and if I will move for 2 pi under root L by G, I have to find out the dimension formula of this. As you can see, this 2 pi is the numerical value. Numerical value has no dimension. So I have to move for L and G. What are the dimensions of length? Definitely it is L. And G. G stands for acceleration due to gravity. Simply acceleration has the dimension formula of LT minus 2. So I have to write LT minus 2. When I just simplified it, we can get T. So again I can say this formula is dimensionally correct. But as I've already told you, 2 pi is a numerical value. So maybe this formula is numerically correct or may not. I will teach you today the application of dimensional formula. In the previous units we discussed the homogeneity of the equations. Now we will discuss about the conversion of units. Any physical quantity, as we know, required two things for its expression. One of its numerical value and the other is units. So suppose if I will just consider two sets of units. Suppose I am taking one set as SI unit, like international unit system, that is meter, kilogram, second system, and another one is CGS system, like centimeter, gram, second system. So when we considered different, if I will consider the different unit for base quantity, all derived quantities have different units in different base systems. So one base system, how many units of one base system is equals to how many units of the second base system is defined in this conversion of units. By this way you can equate two systems, two base unit systems. So for that, what you have to do, suppose I am just taking an example, the SI unit of pressure is Pascal. As I have told you, SI system, which is meter, kilogram, second system. Now if I will convert, I am taking another unit system like CGS system, then what is the unit of pressure in that system, in CGS system? Suppose in CGS system the unit of pressure is 1 CGS unit. So 1 Pascal is how many units of CGS system, CGS unit? We have to find out 1 Pascal is how many CGS unit of system, because I am considering two system here. One is SI system, another one is CGS system. How we can get this? For this we have to proceed. First of all, I have to write down the formula for pressure, that is pressure equals to force upon area. Then I have to find out the dimensional formula for pressure. Dimensional formula for pressure. For that I have to write down the dimension of force, then area, and from that I will get ml minus 1 t minus 2. You have to remember this too also, because when you are going to dimensional system you have to find out the dimension of pressure, that is ml minus 1 t minus 2. Clearly for m stands here for mass, l for length, t for time. So if I will take into account of this, any physical quantity, one more thing is there. Well, any physical quantity, any derived quantity requires two things: numerical value and the units. And the product of numerical value and the units will be constant. So what you have to do, you have to equate these two. U1 should be equals to N2 U2. This is the unit system in the first system, and U2 is the unit in the second system that I have considered. So I have to find out what is the numerical value, that is also called conversion ratio. So I have to find out the value of N2 in the second unit system. So the N2 should be defined as N1 and U1 upon U2. Unit system U1 by U2. For that I have to write down like this: N2 equals to N1. This is M1 upon M2 to the power, this is power 1 as dimension here, and L1 divided by L2 power minus 1, T1 divided by T2 power minus 2. Now I have to write down the units, that base unit as we studied earlier. For this N2, what is the N1? What is the numbers in the numerical value of pressure in the first unit system? That is 1. I have considered this 1. So I have to write down 1 here. I can change it also. I can take any of the value, 5, 6, whatever it is given. Now what is the value of M1? That will be 1 kg in the SI system. So I have to write down 1 kg. For M2 in the second unit system, in CGS system, it is 1 gram. So I have to write down 1 gram and the power is 1. Similarly for length, I have to write down 1 meter. For L2 it is 1 centimeter, power minus 1, and T1 1 seconds, T2 is 1 second, then the power is minus 2. So I think you got the point. N2 will be given by N1 and U1 by U2, and you have to put the base units U1 and U2 properly so that you can find the relations. Now what is 1 kg and what is the relation between 1 kg and 1 gram? Clearly 1 kg equals to 10 to the power 3 grams. So if you cancel out the grams, you can get 10 to the power 3. So it will be 10 to the power 3. For meter it is 10 to the power 2, 10 to the power 2 and power minus 1, and this is 1 to the power minus 2. So by solving this you can get 10. So the numerical value or the conversion unit here is 10. So you can say the numerical value of 1 Pascal will be equals to this. For this you can write 10 CGS unit. So in this way you can convert a 1 unit system into another. Today we will discuss how to derive a relationship, or we find a relationship between the physical quantities with the help of dimension formula. Sometimes dimensions can be used to deduce a relationship between derived physical or any physical quantity which depends on certain other physical quantities. If one guesses this relationship is of product type, here it is worth noting, if the relationship is subtraction or addition type, then we can't derive that relationship between the different physical quantities. So we can deduce the relationship only when this relationship is of product types. So we will take an example how we can deduce the formula, we can deduct the formula by the help of dimension analysis. Suppose I am just considering an example where the frequency of a simple pendulum depends on mass of the ball, length of the simple pendulum, and the acceleration due to gravity. Now I have to proceed how I can deduce the formula, or how I can get the relationship between these three. So first of all I have to write the frequency depends on which factors. It has to be remembered it is of product type. So the frequency should be proportional to what I have told you, the mass. So what you have to do, you have to put a dimension constant A on the mass, you have to subtract it. For length you have to put B, any dimension, other dimension constant, and the third one G, you have to put C here. If this relationship is dimensionally true, then I can say the dimension of the left side and the dimension of the right side should be equal. So what the further steps? I have to write down the dimensions of all physical quantity. So this is frequency. What is the dimension formula for frequency? It is T to the power minus 1. For this proportionality sign I have to write out equal, and if you replaced a proportionality sign with equal sign, you have to put a constant. But a constant have no dimensional formula, so you need not to write a dimension formula for a constant value. So you have to write down the dimension formula for the physical quantity that is written here. The physical quantity here, m, stands for mass. So you have to write down the dimension formula m to the power a. This is the length. So for dimension formula, length is L and the power is B. And the G, dimension formula for gravity, acceleration due to gravity, is L t minus 2. Remember, acceleration due to gravity or acceleration should have the same dimension formula, so it is L t minus 2. Now you have to compare the dimension formula from both the sides. So first of all, you have to write it like m to the power a, L to the power b plus c, t to the power minus 2c. And here, as there is no sign of mass and length, so you have to put m to the power 0, L to the power 0, t to the power minus 1. Now you have to compare the dimensions of same units. So what is the dimension of mass on the left side and what is the dimension of the mass on the second side? If you compare these two, you can get E equals to 0. In the similar pattern, if you compare the dimension formula for length on both the sides, you will get 0 from left side and b plus c on the right side. So you can get b plus c should be equals to 0. Thirdly, dimension formula for time, it is minus 1, here it is minus 2c, so I have to write minus 1 should be equals to minus 2c. When you solve this, you can get c equals to 1 by 2. And if you place this value of c equals to half here, you can get b equals to minus half. Now you have a dimension constant a, b, and the value of dimension constant of a, b, and c. You have to put this value in our equation first. So when you place here mu proportional to m to the power 0, L to the power minus half, and g to the power half, you can clearly get the point m to the power 0. When the dimension is 0, it is not related, it means this frequency is independent of mass. So you can get mu equals to, now again I am saying, if I want to replace this proportional sign, I have to put a constant. Let the constant is k, and this is g to the power half, it means under root, L to the power minus half, that is divided. So it will be frequency, the formula for frequency will be equals to k under root g by L. Here it is worth noting, we can't find out that constant value properly until and unless I know the value, what should be the value of constant. So this is the limitation also. So here we have to think what are the uses of dimension formula and what are the limitations. If I will talk about the limitation of the dimensional formula, I have clearly seen the constant, until we know the value of constant, we can't put the dimension formula. So the value of constant, so first of all I have to consider, we can check out we can deduce the relationship dimensionally, we can relate it the physical quantity, but we can't write down the constant value in the formula. Secondly, we can deduce the relationship only when it is a product type. If it is not product type, we are unable to find out the relations. Third of it, the limitation is we can't get the relationship of any physical quantities if it depends on sine theta, exponential function, logarithm functions. We can't get that relationship because they are the constant values also. So, and these are the limitations when we are using a dimensional analysis to get the relations. Thank you.